Welcome to the Stage 4 Capstone, the moment where everything you've built across the routing lessons comes together. Over the next few minutes, we're going to step back from individual protocols and look at how OSPF, EIGRP, BGP, and redistribution all fit into the kind of design decisions a senior engineer actually makes. Think of this as the bridge between knowing the commands and trusting your own judgment. Here's the path we'll walk together. First, we'll weave all 8 Stage 4 lessons into a single mental model, one cohesive way of thinking about routing. Then, we'll sharpen your instinct for picking the right protocol in any scenario before rolling up our sleeves on a real multi-protocol enterprise ticket. And we'll close with a quick self-check and a look at where Stage 5 takes you next. Let's quickly retrace the ground you've already covered. Lesson 26 grounded you in the forwarding mechanics, lookup, TTL, rewrite, forward, and from there you layered on static routes and floating backups, then distance vector thinking with RIP and EIGRP's dual successor logic. OSPF brought link state and Dijkstra into the picture, multi-area design taught you to scale it, BGP introduced path vector and AS path attributes, and redistribution showed you how to bridge protocols with policy. 8 lessons, 1 coherent toolkit. So here's the judgment call a senior engineer makes every day. Which protocol fits the situation? Fewer than 5 routers with 1 path, static wins, no overhead, home office with 1 ISP, static plus a default route. Multi-vendor enterprise needs OSPF for its open standard scalability, while a Cisco-only shop can lean on EIGRP for simplicity. Touching another autonomous system means BGP. It's the only real answer. And when worlds collide, redistribution with route maps bridges them carefully. Once you've picked the right protocol, the next leap is designing the routing domain itself, and senior engineers all converge on the same 5 rules. Build hierarchy. So backbone and branches each have a job. Summarize at every aggregation point so tables shrink and convergence speeds up. Run 1 IGP internally with BGP only at the edge. Filter every redistribution boundary to kill loops before they start, and always plan for failure with backups you've actually tested. Internalize these and your designs stop being configurations. They become architecture. So let's put those principles to work on something real. Brief 4022 lands in your inbox. 3 offices across Budapest, Vienna, and Prague, mostly Cisco gear, 2 ISPs at headquarters, MPLS connecting the branches, and the business wants sub-second failover with ISPA preferred. That single paragraph hides 5 decisions you have to make: which IGP to run, whether BGP belongs at the edge, how to advertise internal routes outward, how to steer failover with local pref, and how to keep IGP and BGP from feeding each other loops. This is exactly the kind of ticket where senior judgment shows. And here's the topology that answers those decisions. OSPF on the inside, BGP only where it needs to be, right at the edge. Headquarters core sits in Area 0. The 2 branches hang off as Area 1 and Area 2 over MPLS, and HQ Edge speaks eBGP to both ISPs from A65000. The redistribution line between Edge and Core is where the 2 worlds meet and where route maps and local pref will quietly do the heavy lifting to keep ISPA primary and ISPB warm in the wings. Now let's nail down what actually runs where. HQ Edge wears 2 hats, eBGP outward to both ISPs and OSPF Area 0 inward, with redistribution stitching them together. HQ Core is your ABR, gluing Area 1 and Area 2 into the backbone, while the branches stay as plain standard areas. And the BGP trick that makes ISPA primary? A simple inbound route map setting local OSPF to 200 on ISPA and 100 on ISPB. Higher wins, failover is automatic, sub-second. That's senior level judgment expressed in 4 lines of config. Time for a gut check. 10 questions, 30 seconds each. If you can rattle these off without hesitation, you've genuinely earned your routing stripes. If any of them make you pause, the lesson number is right there on the right. Jump back, refresh, and come back stronger. Don't skim this. A senior engineer is someone who can answer the order of operations, AD values, and BGP path selection in their sleep, because those reflexes are what keep production networks running. And if you pass that gut check, take a moment. This is what Stage 4 mastery actually looks like. You can read a routing table at a glance, drop in static and default routes for any topology, run multi-area OSPF with clean summarization, peer with ISPs over BGP and shape policy, redistribute between protocols without leaking chaos, and troubleshoot using administrative distance, metric, and prefix match. That's not coursework anymore. That's a senior routing skill set. With that foundation locked in, Stage 5 shifts gears into the services that sit on top of routing, the protocols that make a working network actually usable. Across 8 lessons, we'll go deep on DNS, level up DHCP with proper IPAM, take NAT and PAT well beyond the basics, then layer in QoS, multicast, NTP, and SNMP-based network management. Routing gets packets there. These are the services that make people care. Before we step into that next stage, lock these 5 mental models into long-term memory. Every routing decision follows the same path. Longest prefix wins, then lowest administrative distance, then lowest metric, with ECMP when paths tie. Reach for OSPF in mixed environments. EIGRP when you're all Cisco, static routes for the small and predictable. BGP owns inter-AS, multi-area OSPF with summarization scales cleanly, and redistribution, always filter, always tag. Internalize these and you're already designing like a senior. Here's your cheat sheet, the one page worth pinning above your desk. Decision order, the AD and metric values for every protocol you'll touch, OSPF area structure, BGP's path selection chain, and the redistribution and route map primitives. When a design question lands on your desk at 2 in the morning, this is the table your brain should already have cached. Screenshot it, print it, tattoo it, whatever it takes. And that closes Stage 4. You've earned it. Routing is no longer a collection of protocols. It's a design language you speak. Next up in Lesson 34, we open Stage 5 with a DNS deep dive. How names become IPs, and why that lookup is the quiet backbone of everything we just built. I'll see you there.